Hello, it's Keith here and welcome to another lesson of the Simple series. Today we're going to be looking at how to do a simple bitmap on the Atari Lynx. The Atari Lynx is a bit different to the other systems we tend to cover because most of them are 2 or 4 colour systems, but the Atari Lynx, despite its tiny size, is a 16 colour system. So let's go over to the source code and let's see today's example in action. Okay, so we'll be running this on the Lynx. We do have 2 examples on this system, which you'll know if you've seen the other episodes, but maybe you haven't. The first one, if we just fire it up here, is just as you can see here, just a simple little smiley face, so nothing too exciting there. And then the second one is a much more interesting one maybe, and that's our Chibico mascot here. So we'll just move that out of the way and we'll have a look at today's example. Now, we'll just start on the simple one. Now the Atari Lynx actually gives us a relatively easy going of things when it comes to the screen and getting things working. Now on most of these systems we'd have to do some complex mathematics or maybe set up a display list, but the Lynx doesn't really give us any hard time with things. The only thing that is a bit tricky is getting the screen turned on. Now the example I'm showing here works on the emulators, but I think there may be some code that's missing for the true hardware with regards to the screen refresh. I'm still trying to work that out because I don't have the hardware to test that. But if I find out there's more code needed to be added, I will add it to the examples. So if you download the sources 7-zip, you will find any fixes that have been required. But anyway, for today's example, we're going to be using this, and the first thing we're doing here is we're setting up the address of the display here. Now we're setting the display to C000, that's the address in normal memory that will be the actual visible screen. So all we're needing to do here is we're setting the low byte to 0 by using the 65C02 command STZ, and the top byte to C0. The order you do things is important here. If you do the high byte first and then the low byte, when you write a low byte, it will zero some of these settings bytes, so just be careful of that. I did make that mistake when I was trying to do the sprite example and I was being driven crazy by it, so just bear that in mind when you're setting your hardware registers of the Lynx. Now we're defining a palette here. I'm defining the black background, purple sign and white that the Chibico character needs. I'm not going to go into any more detail on that. And so now we come to the actual code that's going to do the bitmap drawing. Now, just before we have a look at that, we're going to have a look at the bitmap here. So here's the smiley face bitmap. Now, each nibble, each sort of digit here is one color. So you can see zeros here are the black background and 1 is color 1. 2s are the smile and 3s are the color for the eyes. And you can see maybe that makes up a smiley round face there. So that's our bitmap image. The other thing we've got that's very important to this example is the get screen pos function. This will take an XY position and it will convert that to make a memory address. So what we're doing here is we're transferring an XY into the memory address for when we want to draw to that position on the screen. Okay, well, how do we do that? Well, of course, our screen starts at C000, and we're going to have to calculate the number of lines times the width per line. Now, the width per line is hexadecimal 50 in bytes, and then we would add the X position. Now, the way we do a multiplication on the 8-bit processors is what we do is we do bit shifts. Now, to affect 50, the way we're doing it is if you look at the bits, hexadecimal 50 would have a 1 bit here and a 1 bit here. So what we're doing is we're loading our Y position into the top byte, we're right shifting it till it gets to this position here, just here, and then we are continuing to right shift it to this position, and then we're adding this calculation and this calculation together, which is the equivalent of multiplying by 50, and it's faster. So that's what we're going to do. Then of course we've just got to add our C000 part here for the base, and of course add our X position. And where's that? Just here, there it is. So that's what we're doing here. So you can see here we're loading Y into the top byte here, and we're using the accumulator as the top byte. We're then rotating any bits into the low byte, which we're using C for here, and then we are storing the result into D here, so we get the accumulator. We're then continuing to shift to the right, effectively moving to the second position just here. We're then adding that to the previous calculation just here, and we're also adding the screen base here, and then we're adding this to our DE running total here because we've been using C as a sort of temporary variable up here, and then we're adding any carry, and finally we're adding the X position and just again any carry here, and that will calculate the memory address of a pixel on the screen from an XY calculation. Now you've seen these C's and B's and things. These are 0-page entries. I tend to label these a bit like the Z80 registers. It makes it easier for me to think of them. So that's how I tend to do things. Once we've got that routine, we're then in a position to draw our bitmap. So our bitmap is 8 pixels wide, but there's 2 pixels in each byte, so it's 4 bytes wide and 8 bytes tall. Now we're loading the source address of the bitmap data into the HL pair here, and then we are calculating the screen address of the start with this code just here, with that get screen pods we looked at just a moment ago. Our procedure now is going to be to transfer all the bytes of each line, then move down the line and repeat until we've finished our image. So what we're doing here is we are zeroing the Y register here, and then we are using that as an offset for each line. And what we're doing is we're taking in a byte from the source bitmap, storing it to the destination, the screen, and we're just repeating that until we've done the width of the smiley, the 4 bytes here. Once we've done that, what we're doing is we're adding the Y counter to the current start position in the bitmap, and then what we're doing is we're moving down a line. Now, because we never changed DE in this part, we don't need to reset DE in any way. We just need to move it down to the next line. And if you remember, each line is 50 in hexadecimal wide, so we just add hexadecimal 50 to our DE memory address here, and that will update the destination for the next line. What we're doing then is we're just checking if we've got any lines left to do by just checking our X register here, and if we have, then we're just jumping back up here and we're repeating accordingly, and that will draw the simple smiley onto the screen. Okay, well, what about the more advanced example? Just fire that up again. So what about this more advanced example here then? Well, of course, our bitmap image is a much larger size here, but essentially the code hasn't changed here. We've just got the same code here. Everything works exactly the same. Ironically, the code's a little bit more complicated for the small example here, but the larger example is basically identical, and you can use this code for any size you want. Now, on the Lynx, the hardware sprites are pretty tricky to do, but the software sprites are so fast because of the powerful CPU, the easy access to the video memory, and also the small size of the screen, ironically, that maybe you could get everything you need to do without actually worrying about hardware sprites at all. And that's certainly what Grime 6502 did, and I had to slow it down for the Lynx because the Lynx was quite fast. Now, if you want to create an image in the Lynx format, you can use Accu Sprite Editor, my free open source sprite editor. And you've got Save Raw Bitmap, which is the correct option for today's example. We've got options for hardware sprites here. I have covered hardware sprites in a previous tutorial, but that's going to be too complex for the simple series. So, if that's what you want to do, please have a go at that, and that should help you out. So there we go. That's the basics of getting a bitmap to the screen with the Atari Lynx. So I hope you found that interesting. If you're interested in the Lynx, please take a look around my website, my YouTube channel, because I've got an entire playlist of Lynx examples already. We've done loads of other stuff on the Lynx, including sound and hardware sprites and things. So, check that out. I'm sure there'll be something of interest to you. Anyway, that's enough for today's episode. Please follow along, like and subscribe and that kind of thing, because we're going to be coming back to the Lynx and we're going to be adding joypad control and moving that smiley around the screen. So stick around for that. If you want to see some other system, I got loads of the systems I cover. I do Z80, 68000. I do most of the main systems nowadays, the Spectrum, your C64, your Nintendo Famicom, your Super Famicom, so Super Nintendo rather, sorry. There's probably some other stuff that you'd be interested in. Have a look around, see what you think. But anyway, whatever you decide to do, I hope you'll enjoy programming the Atari Lynx, and I hope you'll enjoy programming in general. Thanks for watching today, and goodbye.